Hello, Sanctioners, and welcome to
Sanctioneering.
Click the links in the description to get to the playlist or view any PDFs on my website, Sanctioneering. Hope you enjoy. Hola, Sanctioners, and welcome back. We're doing example 4.23 in Richard M. Felder's chemical process analysis, and we're doing mass balances. We're doing a ton of examples first, and then we're going to be doing a ton of problems. So in this example, we have a batch mixing process. Okay, so two methanol water mixtures are contained in separate flasks. The first mixture contains 40% by weight of methanol. The second one contains 70% by weight of methanol. And they have 200 grams of the first mixture is combined with 150 grams of the second, 200 grams of the first mixture. What are the mass and composition of the product? Okay, interesting. So why don't you go ahead and try this out by yourself first and come back to me in 3, 2, 1. So let me start with a drawing to give this a little bit of intuition. So two methanol water mixtures are contained in separate flasks. So methanol and water, right? So this is our first flask, this is flask 1, and this is our second flask, flask 2. And they both have methanol, which I'm going to use M for methanol. The book might use MEOH because that's like the OChem way of writing it. And then I'm going to use W for water. Okay, so W is water. The book might do H2O. Okay, so in this one, there's 40% by weight of methanol. So this is, well, simply going to be 40% by weight of methanol. And this one is going to be 70% by weight of methanol. And this is all by weight. And for the water, well, you just take the balance of it, right? Mass balance, 60% by water and 30% by water. Okay, this is by weight percent. So what they do, they add these two together into the same mixture, and now we have to calculate the the overall is going to be 200 grams of the first one and 150 grams of the second one. So we can do some like M1, V1, M2, V2 type of thing, but as a chemical engineer, I think we're going to do the chemical engineering method, right? So what we're going to do is turn this into a mass balance problem. So I'm going to draw the mass balance right over here. So the first one, so this one. So this is going to represent stream 1, which is going to be our first glass, our first feed, and our second glass is going to be second stream. So let's rewrite this over here. So 40% by weight. Let's talk about the mass fraction first, actually. So 40% by weight. So 40% by weight means that for every 40 grams of methanol, there's going to be 40 plus 60 grams solution, right? Does it make sense? Think about it. Think about it for a sec. So 40 plus 60 is the total, right? Because this is the total. This is the total. And this is the component. The component. If you think about it, it'll make sense. I remember I was like really struggling with the concept of mass fraction. It's really not that bad. So you just have the component, which is 40, and the rest of it, which is your balance, your 40 plus 60. Okay. So the mass fraction. So the mass fraction of methanol in stream 1 is 0.4, right? Makes sense, right? So now we have this as a representation. So we have the mass fraction of the methanol in stream 1 is 0.4. And similarly, the mass fraction of stream 2 of methanol is 0.7. So because it's 70 weight percent. So the mass fraction of methanol in stream 2 is 0.7 because it's 70% by weight. So now similar, we can do the balance. So the mass fraction of water in stream 1 is going to be 0.6. And the mass fraction of water in stream 2 is going to be 0.3. And we already have some values for the feeds. So we're going to say that this is going to be 200 grams, right? And this is going to be 150 grams, okay? And then our final stream is going to be our product. And we know right off the bat, it's going to be 200 plus 150. So let me show that. The product is going to be feed 1 plus feed 2. Oops. The product is feed 1 plus feed 2, which is 200 plus 150. So the product is going to be 350. So in total, we should have 350 grams of solution. Now the question is, what is this solution? What is the mass fraction of methanol in the product? And what is the mass fraction of water in the product? And how we're going to do that? We're going to do mass balance. So we already did our component mass balance, we already did our overall mass balance. Now we have to do our component mass balance. So let's start with methanol because they keep talking about methanol. So we're going to do our methanol mass balance, MMB. That's not funny, why am I laughing? So our methanol mass balance is going to be whatever the mass of methanol in the first stream. So the mass of methanol in the first stream plus the mass of methanol in the second stream is going to be the mass of methanol in the product. Okay, so we don't have any exact numbers yet. However, we can calculate them. Since we know the mass fraction is 0.4, well, what does that mean? It means that the mass fraction is going to be the mass of the methanol in the first stream divided the mass of the first stream. Does it make sense? Because by definition, mass fraction is whatever component you're looking at divided by the total mass. And lo and behold, we have our first equation because the total mass is 200 grams. So therefore, the mass of methanol in the first stream is going to be 40% of 200 grams. We can calculate, or that's going to be 80. Do the calculation in your head. So this is going to be 80 grams. So if that makes sense, go back and try it again. And by that logic, you can calculate this guy as well. So if you want to do it quickly, it's going to be 70% of 150, which I don't know what that is. It's 75. I don't want to mess up on camera, so I'm just going to use my calculator. 0.7 times 150, 105. It's going to be 105 grams. And now we know the mass of the methanol and the product. So we can just add these two together. That's going to be 1. So the mass of methanol and the product is going to be 80 plus 105 is 185. And if you didn't follow where I got the 105 from, it's simply the total mass of the stream and stream 2. So let me make sure we understand that. So the mass fraction of the methanol in stream 2 is 0.7, right? And we take the mass of the methanol in stream 2 divided by the total mass of stream 2. The total mass of stream 2 is 150. So solving algebraically, then we have the mass of the methanol in stream 2 is 70% of 150. And that's how we get this 105 value. And now we have the mass of the methanol in the product. Cool. It's going to be 185. And now we have two options. We can do this again, or we can just take a nice little shortcut and we can do a mass balance in stream 3 right here. We say that the product is equal to the mass of the methanol in the product plus the mass of the water in the product. Oh, excuse me, this is not the mass fraction. This is not the mass fraction. This is the mass of the methanol in the product. 185. So we know the mass of the methanol in the product is 185, and we know the product is 350. So if you plug in 350 plus 185, we can solve for the mass of the water in the product by simply subtracting them. We don't even have to do this all over again. We can just simply subtract them. So I'm going to say 350, do some algebra in your head, is going to be 350 minus 185, 165, right? 165. So we know the mass of the water in the product. It's going to be 165 grams. Easy, right? And now we want to solve for the compositions. So the mass and the composition, the mass we just solve for, that's the mass, but the composition means what's the fraction. So all we have to do, one more time, solve for the mass fractions. So the mass fractions, so let's do the methanol again. So one more time. So the mass fraction of the methanol in the product is going to be the mass of the methanol in the product divided by the mass of the product. Okay, so we know the mass of the methanol in the product we solve for is 185 divided by the mass of the product from our mass balance is 350. So we can divide 185 divided by 350. It's going to be 0.52. 52% about. If you're doing your homework, you got to put in your sig figs and make sure it's really accurate, but I'm just going to say 52%. And we know right away that the mass fraction of the water in the product is simply going to be 1 minus 52%. This is going to be 48%. If you don't believe me, well, watch the last video and see how I did that. You're simply going to be adding, whenever you do mass fractions, they have to equal 1. So 52 plus 48 has to equal 1. But if you want to see me do it, well, I'll just do it again. So the mass fraction of the water in the product is going to be the mass of the water in the product, right? Divided by the mass of the product. And we said that the product is 350, and the mass of the water in the product is 165. So 165, divided by 350. 165 divided by 350 is 47. 47, right? I'm just going to round to 48%. Okay, so that is our answer. That is our mass fractions. We solve for the mass fractions and we solve for the masses themselves. And we're starting to get a hang of this mass balance thing. And now this can be useful if you join a research lab. Now you can calculate the mass fractions of your solutions if you want to do that. So there's two ways. There's the Gen Chem way or the chemical engineering way. So I hope this makes sense. Now from here on out, they're going to start to get a little tricky. Now for someone like me, I was really struggling with mass balances. If you just take it a step back and you understand what's really going on in the system, kind of explain to yourself, then it should make sense to you, because all of this is really, it's supposed to be intuitive, because these chemical engineers for the past 100 years or so, they've been developing equations, they've been developing techniques to understand processes and solve problems on a large scale. So I haven't really talked about the whole purpose of this class, at least not yet. If I have, check out those videos. But for now, we're going to be focusing on problems so that you make sure you understand everything for the midterms, for homework, and we're just going to be doing a ton of problems in the book from here on out. So don't stress too hard, just work hard and try to understand the problems. I mean, at the end of the day, it's really just about understanding the problems. Okay, I'm just rambling. Don't forget to share this with your friends, family, and your dog.